All right, so this is day 2 of MAD. These are the applications. So what we're going to do is take a look at some of our data that we looked at in the previous lesson and actually do an analysis on it now. So up here at the top box, it says the MAD set of data gives us information about how consistent the data is. Consistency tells us the data has less variability. So the lower the MAD, the more consistent the data is, which also means the less variability. So we're going to go back to example 1 from the previous lesson. And we're going to take a look at our students' MADs. So student A was 3.68 and student B was 8. So what we want to do is look at their MADs in comparison to each other. If you can look, both students are in the same math class at West. Their teacher's looking to compare the consistency of the students on their test scores. Which student is more consistent? So student A is going to be more consistent because they have a lower MAD. So student A, because they have a lower MAD. So you can also look at their test scores here. If you look at student A's test scores, they're all relatively in the same kind of range. Most of them are in the B category with that one that's down at a 78. If I look at student B is at a 70, and then an 85, a 72, a 95, and then an 83. You can kind of see that there's a lot of fluctuation in their scores, which is showing that there is less consistency. So that also makes sense. So student B has less consistency. Consistency we also call variability, because the scores are variable, and you can see that because this has the higher MAD. And if you look in comparison, the MAD is almost double what student A's is. So there's a lot of discrepancies there. In example 3 of the previous lesson, we looked at the ages of the family members in the 2 different families. So in family A, we had 11.13, and in family B, we had 10.07. Or if you called that 11.1 versus 10.1, that would be fine. So taking a look, clearly family A has a higher MAD, so they have a little bit more variability, a little less consistency. So if we take a look down at these options, the variability is the same for family A and B. The variability is not the same because they don't have the same MAD, so that's out. The variability for A is greater because the mean is greater. So going back, if we kind of looked at this one, our mean was 16.25 and 11.28. So 11.88, sorry. So looking at this one, the variability, because the mean is greater. So looking at this one, if the mean's bigger, that's going to stand out, stand out, stand out, and stand out. We do have a couple pieces that, because the mean is larger, those become big discrepancies for us. So there is a lot of variability. Double check, that one seems pretty good. The variability for B is greater. It is not, so that's out. And then there's not enough information. We are able to determine variability because we found the MAD and we can compare the 2 sets of data, so that's out too. So B is our best answer. The variability for A is greater because the mean is greater, and because there's still some low ages in comparison to that mean, even the 12 really, that is going to cause more variability. If you look, what we can assume to be the parents at 35 and 42 are also a little bit older in comparison to some of the ages of the kids, whereas down here in family B, the parents we would call the 29 and the 35. So with those kind of in mind, they're a little bit on the younger side with the younger age of the kids then too. So there's kind of less variability going on there, just a tiny bit less. If you look at the next example, Alyssa and Beverly scored the grades shown below on their last report card. Which girl had the overall higher average, and what conclusions can you draw? So if I look, Alyssa has all 90s except for language arts, and Beverly has all in the B range. Looks like kind of low to mid B's, so 82 to 85. Notice her range of scores is very low. And that also tells me that my mean is going to be a really good indicator there as a result. Because she has this outlier, the mean isn't a really good indicator. But if I take that out, look at her grades. They're all A's. So if I'm looking for an overall higher average, that would be Alyssa, because overall her grades are higher than Beverly's. If I'm looking though for consistency, Beverly is going to be more consistent. And you can go ahead and assume then if we actually calculated means and calculated the MAD, her MAD would be lower because her test scores are way more consistent than Alyssa's. So last example, Jonathan and Sarah earned the following scores in their last 5 tests. So these are Jonathan and these are Sarah. So who's more consistent? So Jonathan has a 56, an 85, an 89, a 92, and an 88. Notice that 56 in there. Sarah has a 75, 78, 77, 78, and 72, all within the C range, whereas this one went from an F all the way up to an A. So when talking about consistency, so Sarah would be more consistent. And we would be able to back that up mathematically because her MAD would be lower. She also doesn't have an outlier. And really for Jonathan, this lowers his mean. So that'll kind of help us out. So consistency is definitely going to be Sarah because her MAD would be lower. She doesn't have an outlier. And all of her grades are really, if we look, 72 is the lowest, 78 is the highest, are within a 6-point range. Whereas Jonathan goes from failing all the way up to an A.